In this video, we use an Azure DevOps pipeline to run Image Builder. Hello everyone, I'm Travis and this is Seraldos. I've been on an Azure DevOps kick lately, with first deploying a server with Azure DevOps pipelines and then using VS Code with DevOps. In this video, we're taking it a bit further by using a pipeline and Azure Image Builder to automate the image build process. Before we get into that, please subscribe, like, and share. That helps my channel grow so I can keep doing these videos. Click the bell icon for notifications of new content. And if you'd like to learn about Windows Virtual Desktop, check out my course, Zero to Hero with Windows Virtual Desktop on Udemy.com. Speaking of Windows Virtual Desktop, the image used in this example is a Windows 10 multi-user OS for Windows Virtual Desktop. The goal is to automate the image build process for monthly patching or any other image updates. The process will work for other images, not just Windows Virtual Desktop. You can use this with Windows Server if you want to keep an internal image up to date, or Linux images as well. This video focuses on the pipeline process. Knowledge of Image Builder going into this will be helpful. I have a 3-part series on Image Builder if you need more information. The playlist can be found on a link above or in the links below. So let's talk about Image Builder for a second. The process for building an image as outlined by the documentation looks like this. We start with an Image Builder ARM template. I like to refer to this as an image recipe. It includes the steps to build the image. We deploy that to Azure. It creates a resource group used as the kitchen if we keep going with a recipe analogy. Then we build the image. This uses commands in the build template, links to external resources such as scripts and source files, to build the image. Once finished, an image is output to the destination, a managed image, storage account, or shared image gallery. So with that in place, all we need to build a new image is update our external content and run the build. Well, what's on the screen is close, but not 100%. Let's look at what really happens, and this will affect how we build the pipeline. We start with our template that has links to external content. This content includes scripts with commands to install software. When we deploy the template, it creates a resource group with a storage account in it. It then downloads any scripts referenced in the template to that storage account. That local copy of the script is then used for all future builds. The process continues on by building the VM, downloading external content, and then outputting the image. The important thing to note is that if we update the external script, that change won't take effect until we remove and redeploy the image builder template. So why not just include the install commands in the image builder template? We could, but that wouldn't change the flow because we can't update the template. The only option available to update an existing image builder template is to remove and re-add it. The takeaway is that any change to the image builder template or scripts referenced in the template will require redeployment. So why not just make that as part of the cycle? Here's the process. We start by updating our deployment. That could be templates, install scripts, or source installation files. Then we deploy the template. This gets the environment ready for the build. Then we run the build process. Once that finishes, we remove the image builder template. With a DevOps pipeline, we can trigger a build whenever the template or installation script is pushed to the repo. Each time that's updated, a new image is created. We're getting close to the lab, I promise. Here are the build steps we'll use for the pipeline. We start by copying the installation script from the local repo to blob storage. This is the file that gets downloaded to the image builder storage account, so we want to make sure that the most recent version is available. Then we deploy the template. This uses an ARM Resource Manager deployment to get the subscription ready for the image build process. After that, we use a PowerShell command to run the build. Once the build finishes, the image builder deployment is removed in the last step. One thing to note, if the first, third, or fourth step fails, the build will fail. This is so the image builder resource group and storage account are left in place if the build fails. We'll need to see the log in that storage account for troubleshooting, so that won't get removed. 2 more points and then we're off to the demo, I promise. I have videos available that were meant as prerequisites for this one. Check out the series on Image Builder for more information on that, or my DevOps videos on things like VS Code and DevOps. Second, and this one is really important, a free private pipeline has a 1-hour run limit. My basic image with a couple applications took up to 65 minutes in some of my tests. If your build goes over 60 minutes, you'll need to add at least one pipeline job or remove some of the steps to shorten the runtime. I did replicate the image to another region. That adds significantly to the build time. Let's get started in Azure DevOps to build the image. Let's get started in Azure DevOps. We'll start by creating a project. Select your organization and add a new project. We'll call this Image Builder Pipeline, mainly because I already used Image Builder for testing. Make it private, go to Advanced, and make sure version control is set to Git, and then Create. Next, let's set up the service connection. This will allow DevOps to interact with our subscription. Go to Project Settings, Service Connections. Create a new service connection. Select Azure Resource Manager. Use the service principal automatic. Sign in when prompted with an account that has owner rights. We're creating a new service principal in this step, so the account needs to be able to add objects to Azure AD. Select the subscription. You can also scope this to a management group if needed. If you set a resource group, the service principal will be limited to that resource group. In this example, we'll leave the resource group blank. Give it a name. Image Builder for this example. Click Save once done. Let's add the files to our repo next. Go to the repo. You can edit this in DevOps if you'd like, but I prefer to use VS Code. So I'll start by cloning in VS Code. I did a video on using VS Code with DevOps. I'll add a link to that if you're interested in learning more. And click Open. And we'll click Open again. Select the location for the repo on your computer. And once again, sign into DevOps if prompted. And next, let's open the repository. Create a new file, or you can copy an existing. This example will add win10 multi-template.json. This example assumes that the template file is already configured and tested. I'm using the Image Builder template from the Image Builder videos. If you're starting from scratch, be sure that all of the files are tested and working. It's easier to test them by running them manually than trying to identify issues while it's in the build pipeline. I'll copy the contents of the file in. Couple things to point out. Notice I'm referencing the zip file with the install source and the install script, both from a blob storage account, connecting with a SaaS URI. The script can come from a public location, such as a public GitHub repo, but most clients wouldn't want assets like an install script publicly accessible. So unlike the Image Builder videos, where I used a public repo for the install script, I'm actually uploading it to a blob container that's protected with a SaaS token. And I have one other change from the original template. The template is set to distribute the final image to a shared image gallery instead of a managed image. Obviously, a shared image gallery needs to be configured prior to deploying an image to it. Next, we'll create the parameter file. Use Control-Shift-P to get to the command palette and search for parameters. Okay, so I have no matching commands. That's because this is a new install. Let's add the ARM template extension. Let's go to Extensions and search for Azure Resource Manager. There we are, Azure Resource Manager Tools. Click Install. And once installed, we can close this out. We'll go back to our files. Now click Control-Shift-P and search for parameters. So we'll select Create a Parameter File. We'll use New. We'll select all parameters. And we'll add it to the same location as the template file. There it is. Now we have a parameter file. We have to make some changes to this though. When we ran the deployment with a PowerShell command, we added the parameters to that command. Here we're going to add them to the parameter file. So first we'll add the image template name. And we can get rid of the comments. And we'll add the API version. And next we'll add the location. Your values may be different from mine, but if you've ran the Image Builder deployment already, you should have the value of these parameters. Next, we'll add the install script. We're still going to pull the install script down from the blob storage account in the pipeline. By keeping it in the repo, it gives us a spot for version control, and we can also trigger build whenever this file is changed and pushed to the repo. We'll create a new file and name this one install-applications.ps1, or you can just copy it to the repo if you already have it. And I'll paste the contents in. Let's save all of our files. We'll verify everything looks correct and then push the change to the repo. So we'll go to version control, add all the changes, add a message next. And once we've committed, we'll do a push. Let's go back to DevOps and build the pipeline. We can start by refreshing repos. And there are the 3 files we added. Now there's a couple ways to build a pipeline. You can do setup build from the repo. Instead, I'm going to come down to pipelines, create a pipeline, select Azure Repo Git for the code location. We'll select the image build pipeline for the repo, use a starter pipeline. And the first thing we'll do here is comment out the trigger master. If you highlight a block and do Control/, that will comment out the block of code. The trigger master will run the pipeline every time a merge happens to master. We may want that once this pipeline is set up and tested, but for now we only want to run it manually. Let's go to the next line, and we'll add trigger none, PR none. With this configuration, the pipeline will only run manually. We're going to add some variables next. We'll use these in the pipeline. It makes the pipeline more portable. So go to Pool Settings. And under Pool Settings, we'll add these variables. I'm copy and pasting these in to spare you from watching me type. This YAML file will be available for your reference in my GitHub repo. The format for the variables is name and then a value. We have the location for Azure Image Builder, the Image Builder resource group, and the template name. And again, these should all be set if you've deployed the template manually. Next, we'll scroll down to Steps and delete everything under Steps. The first step of the pipeline will copy the install-applications.ps1 file to the storage account. This way, whenever the image builder runs, the most recent copy of the install script is copied to the storage account first. Remember that this file is copied to the image builder storage account and referenced during each build. Also, formatting in YAML is very important. Make sure the cursor is on the line under Steps and one tab over. Go to Show Assistant. Search for File. There is a Azure File Copy task. This uses AZ Copy for the build process. Our pool is based on a Ubuntu Linux, so we can't use AZ Copy. Instead, we're going to use the Azure command line interface, so search for CLI. We'll select Azure Command Line Interface. Select our connection, Image Builder. The script type will be shell. Change the script location to inline script. This will run the commands from the pipeline file itself. Enter the commands. Again, this will be in the GitHub repo if you want to copy and paste. This simply runs the AZ storage blob update command, specifying the storage account, container, and the file name for the source and destination. The source is the install applications.ps1 file in the local repo. Click Add when finished. And now we have our first step. It looks good, but let's add one line that wasn't an option in the helper task. Under Task, add display name, copy install script. Notice I tabbed over twice, and it should autofill for display name. If it doesn't autofill, that likely means you're in the wrong spot. So adding a display name makes reading the steps easier when the build happens. Go to the end of the block, click Enter, and we have to go one tab from the left. Let's add the deployment task. Go back to Helper Task and search for ARM template deployment. Leave the scope as resource group, and the connection is our service connection. Select the subscription. Under Action, we'll leave it as Create or Update Resource Group. For the resource group and location, we're going to provide variables for these values. This again makes the code portable if you want to create multiple pipelines for different locations. So for the resource group, we'll add $. So this is referencing the variable. And we'll put resource group between parentheses. The same with location. And case is important with this. So now we're referencing our resource group and location variables. Scroll down to template. For a template, add the template name. This example was win10multi-template.json, and the template parameter file was win10multi-template.parameters.json. Leave the rest and click Add. That looks good, but we do need to add two things. First, we'll add a display name. So right under Task, we'll enter display name. And next, we'll add continue on error and set that to true. This way, if the step fails, it will continue to work through the last step that deletes the template. Let's go to the end and add another step. The next two steps will build the image. We need to add the AZ Image Builder module to PowerShell before we can run the build command. Go to Helper Task and search for PowerShell. We'll go to Azure PowerShell, select the subscription. This is our connection object, and switch the script type to inline script. Add the install module command to install the az.image builder module. Scroll down. Select to use the latest installed version, and click Add to add the PowerShell task. Let's add a display name. And we'll call it Install AZ Image Builder. Let's go to the end of the step. We'll create a new line and one tab from the left. And we'll add another PowerShell task. Select Azure PowerShell, select our subscription, inline script. We'll add the command to run the image build task. This uses the variables again for the resource group and the image template name. Select latest installed version and add. Here again, let's add a display name. And we'll call this build image. We're almost there. Let's go to the end and we're going to add another PowerShell task. We'll select the subscription again, inline script, add the command to remove the image builder template. And this again uses the pipeline variables. And then make sure to select latest installed version. Click add. And we'll give this a display name also. We'll call it remove template. So something to note, if the template deployment fails, that's this step, the following steps will continue. But if any of the other steps fail, the pipeline will fail. This is intentional. If the image build fails, we don't want the template to be removed because that would remove the image builder storage account that has the log files we need to troubleshoot the failure. So that's the pipeline. Let's click Save and Run, and we'll run the pipeline. We can watch it run by going to Jobs. And notice that now the steps have descriptive names. It copied the script to the storage account. Now it's deploying the template. The template deployment takes about a minute or two. Now it's moved on to install the az.image builder module. And now it's running the build process. The build process will take some time to finish. In my examples, almost an hour. A private, free pipeline has a limit of 60 minutes. One step that takes my example so long is it's copying the image to the shared image gallery in East US 2, then the image is copied to Central US. That's all part of the image build. You can reduce the time by removing the replica. So let's take a look at that. If we go to the image builder template at the bottom, under distribute, this is going to a shared image gallery in East US 2, and it's set to send a replica to Central US. So you could remove this section, and that would speed up the image build. If you need more time, you'll need to pay for at least one job. We only have one job in this pipeline. You can add a job by going back to DevOps. Select your organization and go to Organization Settings. And under Billing, here it shows I have one paid parallel job. If you want to set that up, you'll need to attach DevOps to a subscription with a payment method attached. Let's go back to the job. As I said, this will take some time, so I'm going to pause here and come back once it's finished. The job finished. Let's go into the Azure portal and verify the new image is there. We'll go to the shared image gallery. Go to our image definition. And here's our version. And here it is. For this example, I have a replica to a second region. I did this because most of my lab is in the Central US region, but Image Builder is not available in Central US. Replicating a copy of the image to Central US makes it available there. Let's try one more thing. Let's go back to DevOps. We're going to go into the pipeline, and we'll edit the pipeline. Earlier, we commented out the first trigger block. Let's uncomment that. Control/. Now comment out the trigger block we added. This is trigger none, PR none. And next, scroll down to the build step. We'll select and then comment this section out. This is just for testing. I don't want to wait for up to an hour for this step to finish, so I'm just setting it to skip the step. In production, you would leave this uncommented. Let's save this and go back to VS Code. We made changes on the remote repo that we want to pull local. Go to version control, and we'll run a pull. Let's go back to our files. Here you can see now we have the YAML file local. And the section that builds the image is commented out. Now you're likely to make changes in 3 locations in the future: the template file, the install application script, or the archive file. This solution won't help with the archive file. You'll need to update that as part of the testing. But let's say we've made changes to the install application file. I'm going to remove these timestamps that were only there for testing, and then save it. So this is emulating a change to the install applications.ps1 file. We save that. Now let's go to version control, and we'll add it. Next, we'll commit the change. Now we'll push the change. So this will push the changed file to Azure DevOps. Now go back to DevOps and to the pipeline. We can see that it's starting to build. The job is queued. And in just a second, it should start the build process. Okay, here it goes. So with the way it's configured now, every time we make a change to a file in the repo and push that change to master, the job will run. This is helpful because if you do make changes to the install application script, such as adding another application, you would probably want to build a new image with that change. That's it. That's how we run Image Builder as a DevOps pipeline. I hope this helps you run your Image Builder jobs more efficiently. Don't forget to like, subscribe, and click the bell icon for notifications of new content. Thanks for watching.